I'll select. Let this start. I let this start. I will do. Yeah, hello, welcome back to Botany first year class students. So yesterday because of some technical issues, I stopped in between. Okay, so the same concept I'm starting now. Okay, with the one what we have stopped as the hydrophytes. So the types of hydrophytes I said, and the morphological adaptations I said, and the anatomical adaptations, there was the disturbance in the video. So sorry for that trouble. So we are rectifying that part today. Okay. So again, I will brief you about this. Morphological. Again, I will just say how to write these answers. Morphological and anatomical adaptations. Okay, these are for hydrophytes. So first of all, when we say the hydrophytes means the plants which are growing in abundant water medium are called as the hydrophytes. So here we are taking about the morphological character. That means the external occurrence of the plant body. So the external occurrence means whenever that comes here, 3 points we need to remember. That is root, stem, and leaves. These are the 3 points what we have to write about this in the morphological adaptations. So the first comes the root. If we know the parts, how to write it, it's a very easy task for us to go with it in a very smart way. Okay, smart way presentation, what we say. Because now we are not in the starting of the 19th century, isn't it? So we have done much more development in the science. So like that only we have to learn the answers also in a technical manner. So the first comes the root. Root system is the poorly developed root system in the hydrophytes. The first one is the poorly developed root system. After that, what we have to write? In some plants, roots are completely absent. So in which plants roots are absent, we have to give the example, because in some plants we mentioned now. So in which plants roots are absent? Example, hydrilla. Example, hydrilla. Okay. Next one is the poorly developed. What is the example in this? Nymphia. Lotus. Okay. And the next comes, in some plants, root system is a very well developed root system, what we can see. Where that is very well developed root system? Amphibious plants. Well developed root system, amphibious plants. You can say only this part also, amphibious, or else you can say the example, that's up to you. The example is the Sagittaria. You can say the example, otherwise you can simply say the amphibious plants. Okay, now comes with the next one. In the root system only, the usually root system will be having the root cap at the bottom. But in this hydrophytes, it's not seen. That means root caps are replaced with root pockets. What we have to say here? Root caps are replaced. That means instead of that, this is present. Okay. Instead of the root caps, root pockets are present. So in which plants we will see this type of root pockets? That is also very important. Root cap replaced with root pockets. Example, Pistia. So remember, this plant name is very, very important in the complete botany. Wherever you will go, that means just like a hutch dog, it follows you. The plant name, Pistia. In degree or anywhere, we have to remember this Pistia word. Okay, and this is the one which is seen in the first type of the hydrophytes, that is free-floating hydrophytes, the Pistia, where the poorly developed root system can be seen, and even the root pockets are also can be seen in the Pistia. Okay, and in the amphibious plants, usually the root system is adventitious root system. In the hydrophytes, adventitious root system can be seen. Example, Vallisneria. And that except the amphibious. In the amphibious plants, taproot system can be seen. Amphibious plants. All amphibious plants are having this type of taproot system. Adventitious root system only in Vallisneria. Okay. Now comes with the stem. Now the root system is, we have done with all points in the root system. Now comes with the stem. Stem is how the stem should be. Stem should be green, erect. Okay, this can be seen only in the amphibious plants. Erect stem, green colored erect stem can be seen in amphibious plants. So what about the other plants? In the other plants, the stem will be showing the different types. In the Pistia, stem is subaerial stem modification offsets. Like that only we have to write over here. Okay. In Pistia, subaerial stem modification as offsets. Okay, offset. Now comes in the nymphia. In nymphia, the stem is underground stem modification. Underground stem modification as rhizome. As rhizome. So like this we have to write. And stem is very small. That in the Vallisneria. Now comes this much only we have to write. Now comes with the last one, leaves. And leaves are again of the differentiation we can see in the different plants. So usually leaves are having the petiole, large leaves, aerial, okay, which are present on the stem. That is in the leaves, the green leaves are green in color, petiolated, large, can be seen in the amphibious plants. Can be seen in the amphibious plants. That also above the water level. Above the water level. There only we will see like this leaves system. And in the another part, that is the plant part that is present below the water, where the leaves are dissected. The word here, what we have to use is the dissected. If you cannot use that word, then you can write it as the small leaves. But word is dissected, means reduced to small grass-like occurrence. That is the dissected leaves, what we will say. So we have to use some specific words over here. That is the dissected. Okay. And otherwise, if you don't know this word, then you can write it as small. Otherwise, we can write it as the needle-like. Okay, anything we can do it, but we have to write it as how they look. Like this, they will be looking. So like this, we have to say the leaf arrangement. Leaves are dissected, small in size in the water. When the plant part is under the water, the leaves are looking like this. So this type of leaves are when same plant is having two different types of leaves, that is called as the leaf dimorphism. Leaf dimorphism. You have to use this word, no chance of skipping out. You have to. So just make a note of leaf dimorphism. Okay, that means leaves are showing two different types of occurrence in the amphibious plants. That is the leaf dimorphism. The word mandatory in the morphological adaptations, only in the morphological, don't use in the anatomical adaptations. Anatomical adaptations means internal organization of the plant body. There, the externally how it looks does not matter. How it is made internally, how the tissues arrangement, which types of tissues are there. At that time, if you are writing all these stuff, they will say that you don't know the subject and whatever you learn, you have written. So they can give only 0 marks if you have written the morphological adaptations or the anatomical adaptations, or else they will say this answer is completely wrong. Anything they can say. So don't take chances right now, where we are going for the improvement exams or else for the supply exams. So whatever may be the exam, where we need to get good score, our aim is to get good score. So don't never forget the aim at any cost. Write on the wall that what is your aim, which type of marks you want to get. Every day, wherever you will see in the morning, the first wall, there you have to paste it, not in the kitchen. Okay, not on the roof of the washrooms. Only where you will see for the first time and all the time. There, if you write that type of captions, that means what is your goal and how many marks you want to get. Every day you have to inspired by those things, and you have to do the work hard. So here, don't think that lecturers are putting pressure on you to read. Your ambition, we are reminding you every day. Instead of your parents, we are remembering you. We are reminding you, not remembering, we are reminding you. Do it, do it, do it, do it. Once we are saying, someone are saying every day, we feel that why they are saying and why they are harassing us. It's not the harassment actually. It's a reminding, just like the alarm in the smartphone. Will you say that mobile is harassing you by reminding the alarms, otherwise the notifications? No, no. Why? Because we want it, we love it. So same thing for the studies and for the lecturers. If you have a good thought, then you never say that lecturers are forcing you to learn the things. We are not forcing. What is your aim? Every day we are reminding you, like that we are reminding your parents also, because at the last moment they will woke up to make the things to be happen perfectly within 1 week time. Nothing can be done like that. If we want to build a 5-story building, then something has to be done. Groundwork should be done 6 or 8 months. Only the groundwork, that is the planning and taking the permissions and from the municipal corporation, that is a different one. I'm not talking that. Only perfect planning with the financial things and to which builder we have to appoint. Otherwise, we have to give the grants for the builder, and how many flats in one floor, otherwise how many portions in one floor. Everything we should have a clear plan. For that planning, it takes, if you are a gem, it takes nearly 6 months time. If you are not working on the work properly, then it takes 1 year time, only the groundwork. That means where you have to come to the conclusion. Like that, the same thing. Why I have given that building? Because we know that. We will say that by sitting over here, by seeing the constructed building, that builder does not have the brain, as if we know everything. we don't know. But is it to blame anyone? Na? So we'll say the builder does not have the brain. How he is using the bricks, so cheap bricks. If you give the good finance, then the builder will use the good bricks. Na? But that means you are lacking with your financials over there. There, within that limit only, he has to buy that things. So he will use the cheap material only. Like that here also, when whatever we are saying, when you are not preparing properly, then nothing can be done and we cannot get our goal. So every day we need to remember our goal, and for remembering, we need to have the reminders, always reminding, and need to work hard, do the hard work on the concepts where you have to get the good score, neat rankings, or everything that's there in our hand, how to mold ourselves. We are the fire, we are the iron, and we are the sculptures to make ourselves. And to do that, the faculties will guide you how to do yourself. Sometimes we will make you, but at last you have to do the things. Okay. So here also same thing, leaf dimorphism, that type of words, whatever I'll say, those words has to occur in the IPA exam. Like that only. No change, no compromise over there. I won't compromise with a few words, what you have to write over there. Okay. And the leaves in Pistia. How the leaf arrangement in Pistia? This is the rosette arrangement. Rose petal-like leaf arrangement can be seen in Pistia. That is the rosette arrangement. And the next comes with the nymphia. In the nymphia, leaves are very big, large sized leaves floating on the water surface, having a thin waxy coating on their surface. That is a lotus leaf. Okay. So like this, we have to write about the different types of the leaves. And the leaves in Vallisneria, that is the submerged rooted plant. In that ribbon-shaped, long ribbon-shaped leaves are present in Vallisneria. Like this, we have to say the different examples. Again, leaves are reduced leaves in hydrilla. So like this, we have to give the occurrence of the root, stem, and leaves in different parts, in different plants in the hydrophytes with the examples. Now now we are going to discuss about the anatomical adaptations of the hydrophytes. Anatomical adaptations means the internal structure, that is the how the tissues and all other things are present in the hydrophytes. Anatomical adaptations. Of hydrophytes. When we are saying this, we have to draw the diagram. If you know the diagram, then the answer is very, very easy for us. So first of all, I'll say the points. In this, the first one is mechanical tissues are completely absent. That's the first one, what we have to write. Mechanical tissues are absent. Fill up the sentence. I'm not writing the complete sentence. Mechanical tissues are absent. That is the first one. And example, pistia, nymphia, you can say. Okay. And mechanical tissues are seen in the amphibious plants. So in amphibious plants, mechanical tissues are poorly developed. Mechanical tissues are poorly developed. This we have to say because this is the special category in the hydrophytic plants. Next comes with the, now we have to go with the other things that are there in the hydrophytes. That is the plant body. Stem is covered with a thin cuticle externally. Example, nymphia, and thick cuticle in pistia. Thin cuticle in nymphia leaves. Okay, and thick cuticle in pistia. In pistia. Next comes the, in the stem, hypodermis is made up of simple parenchymatous tissue. If wherever the, in all the plant system is present, isn't it? So in the stem, hypodermis is made up of a simple parenchymatous tissue, and complete body is filled with parenchymatous tissue. Otherwise, we can say parenchymatous tissue is more in the hydrophytes. So what is the importance of this? This helps in buoyancy, in free-floating plants, and in submerged suspended plants. Example, pistia and hydrilla respectively. Free-floating pistia, submerged suspended is hydrilla. So I have given two words and I said the two examples. Both are related. Respectively means the free-floating is pistia and the submerged suspended is hydrilla. Okay. And the next one is in the stellar region. In the stellar region, xylem shows cavity. Xylem shows cavity-like occurrence in the hydrophytes. Which plants we can say the best example here is hydrilla. We have to give the example. Same thing we are having in 2 marks. Xylem shows cavity in hydrophytes. Why? That means Why it is showing? Because there is no need for the plants to absorb and pump the water to the upper parts. So for that sake only, xylem shows a cavity unnecessary for the plant to develop this tissue. So it says that why should I develop and why should I waste my energy in developing this tissue? I'll show a cavity. So that's the plant intention, very much clear in its duties. The duties which were given to the specific parts, that part has to do that duty at any cost. Whatever our parents will say to us, we'll try to skip off the work. But here, it's not like that. Plant parts has to obey the rules, no option. If not, that function is not necessary for the plant. Then it says that the tissue is also not necessary. That part is also not necessary. So it removes that part itself. So that much very clear in giving the functions and the doing the functions by the specific parts. So here xylem shows cavity. Why? Because the plant is present continuously in the abundant water medium. So no need for the plant to absorb water and pump water. Always it is present in the water. No need of absorption again and again. So for that sake, xylem shows cavity. What you have to write in the 2 marks question for the same one? Why xylem shows cavity in the hydrophytes? Because the plant is growing in abundant water medium and always present in the water. No need of developing this xylem tissue. So it shows a cavity in the plant body. Example, hydrilla. All the plants except amphibious plants. Except amphibious plants, xylem shows cavity. In the amphibious plants, the plant part is above, 3/4 part is above the water. So they need water for doing the photosynthesis. Then it needs to pump the water by the xylem. So their xylem never shows a cavity. Okay. So the 4 marks and 2 marks altogether I am covering. Because my subject is like that. I cannot take it separately. In whenever it comes in here, I'll say and I'll continue. Okay. And next comes the diagram. How to draw the diagram and this. So here we have to draw the diagram for the Nymphia petiole, otherwise hydrilla stem. Take it as hydrilla stem. Because we are saying the xylem shows cavity now. So hydrilla stem TS. TS of hydrilla stem. If you know this diagram and the labeling, you can give the anatomical adaptations of the hydrophytes. First, draw the outline as a circle. Okay, exact circle. And this will be having the epidermis. Epidermal cells are simple parenchymatous rectangular shaped cells placed without intercellular spaces. And all these cells are very thin walled cells. Like this you can draw. Okay. Now I am taking the different colors because you need to understand the differences between the cells. Next one is the hypodermis. Hypodermis is also made up of simple parenchymatous thin walled cells placed without intercellular spaces. Like this. Now comes the what we said already. Xylem shows a cavity. So first of all, in the center, show a cavity. Okay. Now comes with the, and so in below this, it because here the leaves are reduced to, in the hydrilla stem, leaves are like this. Now reduced leaves are present. So we cannot say the leaves are having the mesophyll tissue in them. So both characters can be seen in the hydrilla stem, leaf characters and the stem characters. Both will be done by the stem only. So here the stem, the below the hypodermis, this is completely filled up with parenchymatous tissue. Easy to draw like this, no? Everyone can draw this. You cannot say that I cannot draw this hard diagram. Very easy. Only circles. Everyone can draw. And you need to draw. No option left out. And I'm not asking that you can draw. No, you have to. That's it. Okay. And in this, chloroplasts are present. So put the dots. And here also chloroplasts are present. Put the dots over here also, so that we can say these are the chloroplasts. Okay, so with this, we have finished off this. And in between this, it is having the sclerites, which gives the support. That is a somewhat mechanical support. Sclerites will be present. Okay. Now we can give the labeling part. This is the epidermis. Hypodermis. So when we are writing the hypodermis, never forget to write in the brackets parenchymatous, simple parenchymatous. When we are doing this, we never forget what we have to write in the theory. That is the most important one. Okay. And this is the air space. Actually, we have to give the labeling at one corner, that is on the right side for the diagram. Here, if I will write the letters in a small font, then you cannot able to see this. So I'm giving the labeling on the left side for the diagram also. But you should not do in the final exams, because here if I write in a small letters, then I can give the labeling at on the right side itself. But now here I cannot do, because you need to see the labeling part. So I'm writing somewhat big letters. Okay. So here I'm giving the labeling. This is the parenchyma. And don't say that ma'am has given the labeling all over the diagram. Even we can give. Okay. I'm saying again and again. Should not give. And these are the sclerites. That's it. And the last one, this is the xylem cavity. That's it. With this, we can wind up. So all the things, whatever we have mentioned there, we can easily write in the theory also. That's the botany subject. Theory, diagram, both are running parallel to one another. If you skip out one, the train cannot go smoothly. Okay. And the next one is the anatomical adaptations of xerophytes. What are xerophytes? Xerophytes means the plants which grow in the desert areas, or else we can say the plants which are growing in the water lacking areas, where water is less. When the plants are growing in that area, those are called as the xerophytes. So how to say the thing further, that is the anatomical adaptation, that means internal tissue organization. Okay, so for this we have to Because why I have taken out this? When we have compared, when we have finished the anatomical adaptations of hydrophytes, then immediately I started this. There is a comparison between these two. What are the points you have to write? Only for the hydrophytes, only for the xerophytes. So there is no clash, so that you can easily go for the good preparation for the supply exams, otherwise for the improvement exams, where you can score 60 out of 60. And if you remember these same points again, it's important one for the competitive exam wise. So no need for us to prepare again and again. Once one concept we have done, that is completely fixed in the brain, that's it. The same points we can get as it is in the competitive exam. Those who are writing the MSET, NEET, whatever the competitive exam, I can give you the assurance that based on this part, you will get a damn sure one question in the competitive exam. So well prepared now itself. So that's the one I said, goal should be very clear, where you have to get the good score in MSET or in NEET. Always when we are taking the BPC means NEET, if not MSET. Okay, so both the ones we have to get good score. That's our aim. Even in the IPA, same thing. Okay, once we have prepared for the subject means we should not say that we didn't prepare for the IPA. There in my subject there is no special preparation for IPA. Whatever we are preparing for the competitive exam, same thing we can prepare. We can go with the IPA. Once we have prepared for IPA, same thing we will have in the competitive exam. So I won't accept that I have prepared only for the competitive and I don't know how to write for the IPA exams. You know how to make the sentence, concepts, you can frame the concepts in the sentences. That's it. We don't want any other history behind history. That means 18th century onwards, we don't want the present concept only. So be prepared. And to whom you are talking about which topic, first make sure that and talk. Okay. So even I'm listening with so many students that I have prepared for the competitive exam and I don't know how to write for IPA. As if we don't know English and cannot make a sentence, a small sentence. That should not be there. Okay. So here, anatomical adaptations. So in this, the very first point in the anatomical adaptations are mechanical tissues are well developed in the xerophytes. What we said in the hydrophytes, mechanical tissues are poorly developed. Here, mechanical tissues are well developed. Well developed mechanical tissues are seen in the xerophytes. That's the very first sentence what we have to write. Mechanical tissues means the next point what we have to give the continuation. Okay, don't go away from this concept. Move along with this concept only. Xylem and phloem are well developed. Xylem and phloem are well developed. Same thing we have to write. Okay, in all the plants, there is no exceptional cases in the xerophytes where we will see the xylem and phloem are not developed. It has to be developed. No option left out for the plant. And the next one is hypodermis is made up of cholenchymatous. Otherwise, hypodermis is, can write cholenchymatous. Hypodermis is made up of cholenchymatous tissue. Cholenchymatous tissue. This is a mechanical tissue which gives the mechanical support for the plant body. So we were mentioning that mechanical tissues are well developed. We are going in the same track, same line. We are not going out of the line, just like in the highway. Otherwise, on roads, we are having the fourth track. That is one is for the two-wheeler, another one is for the four-wheeler. That also heavy vehicles. Heavy vehicles should not go just like in the two-wheeler line, isn't it? Like that, Here also we are going in the same track with the mechanical tissues. Hypodermis is made up of parenchymatous tissue. That is the mechanical tissue only. So we have written the same point over here. Now comes with the next point. That is the root system. Okay. And what else we can say? One more thing. In the leaves, what we said in the hydrophytes, leaves are the plant body is having the parenchymatous tissue for its buoyancy, that is floating on the water surface. Here, parenchyma is less. Parenchymatous tissue is poorly seen, or poorly developed, or less present. Anything we can say. Okay. Parenchymatous tissue is poorly developed. And the next one is stomatal apparatus and the cuticle. What we said in the hydrophytes. Cuticle is the thin waxy cuticle, thick waxy cuticle in the hydrophytes. See here, it is completely, the plant body is covered with thick waxy cuticle. This is to reduce rate of transpiration. Reduce rate of transpiration. And in this word has to be present. Okay. This word has to be seen in this, in the xerophytes. Without this, we cannot say whatever you have written is the correct one. Some points are very, very targeting. Okay. So thick waxy cuticle is present to reduce the rate of transpiration. This word again, rate of transpiration, is very, very important. You have to mention. Okay. And the next one is the leaves, what they are having. The leaves are having stomata, isn't it? What is the importance of the stomata? Through the stomata, gaseous exchange can be seen, as well as what else we can see through the stomata? The water is going to be evaporated. That means water vapor is going to be removed from the excess water vapor can be removed from the plant body. For both the purpose, only stomata. In the hydrophytes, stomatal apparatus are reduced. Okay. And here, stomatal apparatus, stomata are present in sunken type. Sunken type. This is again the most important point what we have to say in the xerophytes. Stomata are sunken type. This is to reduce the rate of transpiration again. Okay. And the sunken type of stomata means how they are present. They are present inside the mesophyll tissue of the leaf, so that it can reduce the rate of transpiration in the plant body. So what we said now, the same thing we can see in the diagram also. So here the diagram is the Nerium leaf TS. TS of Nerium leaf. Okay. TS of Nerium leaf. and the leaf is covered on both sides with the epidermis. So the epidermis is made up of simple parenchymatous rectangular shaped cells placed without intercellular spaces. Same words we have to use each and every time. And what I said for the microsporangial wall layer epidermis, same thing. Okay, epidermis is made up of simple parenchymatous rectangular shaped cells placed without intercellular spaces, and it is covered with the cuticle. Okay, and here the sunken stomata. I think this color is not visible, dark green. So I'm using again the light green. Otherwise, I'll make the background as white. Then good. Now you can see this color. This is in the leaf mesophyll tissue. Mesophyll tissue is having again, it is made up of two types of cells. That is the parenchymatous and the palisade tissue. Spongy parenchyma and the palisade tissue. So this is the dark green colored one. Hexagonal cells are nothing but the palisade tissue, which are having the more number of the chloroplast, which is giving the dark green color for the leaf surface. Okay, and next comes the spongy parenchyma. And before that, the central stellar region. This is the xylem. Should be always a hexagonal. Next comes the phloem. It is also hexagonal and placed without intercellular spaces. Gap should not be there between the cells. If gap is there, then they won't be properly arranged and they cannot give the good support. Okay, so this is mandatory one over here. And now I'm drawing the spongy parenchyma. Spongy parenchyma is the circular shaped cells, otherwise the oval shaped cells, whatever may be. Things very fast so that it can be looking good as well as time can be saved for us. Don't go to draw this part only with a large, much more time consuming. The less time we need to consume. Okay. And the next one is the stomatal apparatus. For okay, here the stomata, sunken stomata. Sunken stomata means it is going into the mesophyll tissue, and there the stomatal apparatus are present so that they can reduce the rate of transpiration from the leaf lamina. So how Beautifully, they arranged themselves in the leaf. Look at this. Planning is perfect, isn't it? To reduce the rate of transpiration, their planning is perfect. Like that. So these are the sunken stomata. Okay, what we said in the point, what we have shown, both are related. And these are the hair-like structures which will remove the hot air so that it's easy for the leaf to reduce rate of transpiration. Well planned. When it is making its cells, it's the perfect planning. And this is the cuticle. Upper epidermis. Spongy parenchyma. And this is the lower epidermis. And this is the palisade tissue. And this is xylem. This is phloem. So like this, we have to give the labeling, simple labeling, and the whatever we have given the explanation and we have shown in this also, like this we have to remember the points. If when we are remembering like this the points, it will be easy for us to go to the concept based, as well as we can easily move to the point where whatever we want to stress it out. Okay, and the other SAQs are also there in this chapter, but within 5 minutes time, I cannot complete all the other 3 SAQs. So we will stop till here only and we'll continue with the next SAQs from the 13th chapter as well as from the 12th chapter tomorrow. Okay, we are coming from the back now. So 12th chapter and the 13th chapter SAQs will continue in the next class. Stay tuned to the same channel, same time.